This is one of my favorite conceptual questions having to do with one-dimensional motion. So if I have a person standing on top of a cliff and they have two balls, a green ball and an orange ball. And that green ball they throw up in the air with some velocity v. And that ball is going to go up, and then it's going to come back down, and it's going to hit the ground. The orange ball, they throw downward with the same velocity v. Obviously, it'll be in the opposite direction. And then it will also hit the ground. Compare their velocities the instant before they hit the ground. Will the green ball have a greater velocity, v green? At the ground, will it be greater than, less than, or equal to the velocity of the orange ball? You can pause your video, think about it for a second, and then start your video back up again. All right, so I hope you thought about it in this way. If the green ball goes up, obviously at the top of its motion, that velocity of the green ball is going to equal 0 meters per second. And then as it's traveling back downwards, the velocity will begin to increase in the negative direction. It's going to get bigger, negative. And once it reaches the height at which it was thrown at, it comes back down, it reaches this height at which it's thrown at. This velocity is going to be the same as the orange ball as it's being thrown downward, right? So one's thrown up, one's thrown down. They're both at the same speed. Now, as that green ball has reached the same height, it will have equal velocity as the orange ball, and so equal velocity, equal height, it will take the same amount of time for them to fall, and then when they hit the ground, they will be going the same speed. So the velocity of the green ball will actually equal the velocity of the orange ball. Now, compare the time that they're in the air, though. If this happened at the same time, well, obviously, because the green ball goes up and comes back down and then hits the ground, the time that the green ball is in the air is going to be greater than the time that the orange ball is in the air. This is one of my favorite questions. I just think it's fabulous. So I'm pretty sure that we've talked about a graph that looks like this when it's a position versus time graph. But just in case, if this is a position versus time, what's happening here? Well, at this time, they are at the same position, and maybe we'll call that x2, right? At time 2, they're at position x2. But what happens to, and so if they're at the same position, then in this case, car X is stationary, right? And car Y is moving, and so car Y passes car X, which is not moving, sort of like this, right? Okay, but what happens if this, instead of being a position versus time graph, is a velocity versus time graph? So I'm going to leave my T there, but let's turn this into a velocity. Okay, so what happens when these are velocity versus time graphs then? Yeah, right? Things get sort of weird and complicated. Are these two cars, are they following the same motion? Are they doing the same thing? No, because car X has some constant velocity, right? Meaning it's just going down the road at like 60 miles an hour. But car Y starts at a velocity of 0 miles per hour, and then its speed increases. So car Y is accelerating, it's going faster. So at this spot, is car Y passing car X? Pause and think about that. So at this spot where they intersect, that's just at the time 1, they both have the same velocity. Let's call it V1. So at T1, they have the same velocity, but have they gone the same distance, or do they have the same displacement? And so to think about that, we need to look at the area under the curve. And so at this T1 time, car X has gone has a greater displacement than car Y. If we look at it for the whole time, we look at the whole area under the curve here. Well, then t2, after time 2 has passed, it sort of looks like these two areas are equal. The area of this triangle is equal to the area of this rectangle. So at t2, car y is overtaking or is beginning to pass car x. Up until then, car x's displacement is greater than car y's displacement. But once we get to this t2, car y's displacement is greater and will continue to be greater after that point. One thing that I want to make sure that I hit on really hard is acceleration due to gravity, what's happening to a ball when it's thrown up and when it's caught. And so just for clarity's sake, I'm talking about something that's thrown straight up in the air. It goes straight up, reaches some height, and then comes straight down. So it'll look like this, and then it's traveling down here. So when I look at the position versus time graph of this, that position versus time graph is going to look like a downward opening parabola. Maybe we erase part of this, so it goes up to this height, h. Okay, so the first thing that I want to talk about, this will be h. The first thing I want to talk about is what's the initial velocity versus the final velocity? And so the initial velocity, let's just call it vi, is going to be equal and opposite to the final velocity. So here it's going to be straight up, like 3 meters per second, and here it's going to be straight down 3 meters per second. It spins half the time in the air, so up at the here, this time will be t1 half. And so at each point along here, whatever height it is here, it'll have some velocity, and then when it's at that same height coming back down, it will be traveling at the same speed but in the downward direction. So if I were to draw arrows to represent the velocity, it's going to be big and positive, and then it's going to decrease over time. Up here, the velocity is 0 meters per second, and then it's going to increase on the way down. And I hope that you see that this line is the same as this line. Okay, but what about the acceleration at each point? acceleration. Acceleration. At each point throughout this ball's path, up and down, gravity is pulling on that object down, straight down, no other direction, straight down. And so at each point along this graph, the acceleration is going to be straight down. Doesn't matter if it's traveling up, doesn't matter if it's traveling down, the acceleration is straight down and it's constant throughout the whole time.